This unit is called Systems of Linear Equations. We've already been working with linear equations for like weeks. Now we're just going to have more than one on a graph at a time. So really, you're not learning much new. It's basically the same stuff, and we're just doing something new with it. So the first thing we're going to do is we're going to learn how to solve equations by graphing. If you read the questions, this is some of the more applicable math that we'll actually do in this class. Yeah, it's the same thing, but now it's applicable. So there's going to be a lot of like word problems that you're going to have to solve. So this one, the Smith and Harper families are going to a book fair. Mr. Smith paid $11 for his 3 adults and 1 child to enter, and then Miss Harper paid $12 for 2 adults and 3 children to enter. What we need to do is try to determine the cost of an adult and child ticket, because we don't actually get told that. We just get told what their total was. And the way we're going to do that is by modeling it with linear equations. So there's one there and one there. Which one is modeling the Smith family?
3x plus y equals 11.
3x plus y equals 11 is the Smith family because they paid for 3 adults, that's your 3x, 1 child, that's your 1y, and it costs you $11. So that's equal to 11. Matthew. Right, so this is a pretty easy one to almost just do in your head, right? We're going to do this one solving by graphing because we're going to get to questions that are a lot more complex that you can't just solve in your head real quick. The way we're going to do it is by drawing the graphs. Can we draw these graphs in the form that they're in right now? No, it's going to be a struggle. What type of form would we like to change that into that would make it easy to graph, Josh? Slope point form would work, but we don't really got a point. Slope intercept form would be fantastic, wouldn't it? Yeah. So what we need to do is get y by itself, and I think some of you are struggling with this part of the course, the algebra part of the course. If you are, you know who you are. If you're finding the algebra difficult, you need to start getting extra help like today, because this unit is a lot of algebra. It's a lot of algebra. Josh. That's, I'm going to do them together right now. So, I'll do the first one. Our goal is to get y by itself, and we also want a positive y by itself. So it wouldn't make sense to move the y since it's already positive. We're just going to leave it alone. What we do want to do is subtract 2x from both sides. By doing that, these will cancel out, and we'll be left with 3y is equal to negative 2x plus 12. That's not quite slope-intercept form yet. Slope-intercept form is just y. It's not 3y. So yeah, Matthew, you got to divide both sides by 3, which means you divide everything by 3. And your final equation should be y is equal to negative 2/3, or 2 over 3, x plus 4. That's slope-intercept form. We call it slope-intercept form because it gives us our slope and our intercept. Now to draw that. You guys should have been experts on drawing these things by the time you wrote that test yesterday. You had a bunch of questions in your unit assignment and a bunch of questions in your practice booklet on drawing these types of equations. What you need to do is take your y-intercept, 4, and draw it here. 1, 2, 3, 4. And then you need to take your slope and find the next point. So the slope is negative 2/3. Since it's negative 2, you go down. The negative dictates if you go down or if you go up. If it's positive, you go up. If it's negative, you go down. You always move to the right. Negative, we're going down 2. 1, 2. And then 3. We go over to the right 3. 1, 2, 3. There's our next point. Draw a line. That line represents the cost of tickets for adults, this one up here, for children down there. Right? Yeah, X represents adult. So this is adult. This is children. Alright, let's try the next one. You can try it on your own right now. I'm trying to do the algebra, get into slope-intercept form. If you can't do it on your own, watch as I'm going. So we're taking 3x plus y equals 11. The y is already positive, so we're not going to mess with it. We want to move the 3x to the other side, so we subtract 3x from both sides. 3x minus 3x, 0, it's gone. Now you have y is equal to negative 3x plus 11. And that's beautiful because it's already in a single y. And use green to represent the Harper family. What's just 3x given 1 is minus down from 11 over 1. Exactly. So Joe says the first point is 11, right, Joe? Yes. And he got that from our y-intercept number. And then he said it's negative 3, which means you can just pretend it's negative 3 over 1. If there's nothing underneath, it's just divided by 1. So that way you're given some sort of run. And it's negative, so Joe says it's going down. So we go 1, 2, 3, and then 1 to the right. And there's your new point. 1, 2, 3, over 1. And you'll keep getting points. And you should get a nice little line. Now that you have two lines or a system of equations, you can figure out what the actual cost of tickets were by looking at the intersection. So where these two lines cross, they cross right here. And what you want to find is what that coordinate is. So what is that coordinate? And what do you think the coordinate is right there, that intersection is? 3, 2. So the x value is 3, the y value is 2. And like Matthew said right off the bat, right Matthew? He said that adult tickets cost $3, youth tickets cost $2. That's what this intersection is telling us. That's what that point means. These points mean something now. Any questions? Not crazy hard, right? Okay. Now let's just do some fill in the blank. The equations 3x plus y equals 11 and 2x plus 3y equals 12 considered at the same time are considered what? What do you think we have a name for when we have two lines that we're considering at the same time? We call it a system of equations. So anytime you have multiple equations that you're considering at the same time, it's a system of equations. So if I ever refer to a system of equations, it basically just means more than one equation that you're considering on a graph at the same time. The solution to the system was 3, 2. This is because x was equal to 3 and y was equal to 2 would satisfy both equations. So if you took a peek back, the number x is equal to, or y is equal to 11 and x is equal to 0 would satisfy the green line. That's a point on the green line. But it's not a point on the red line. You're looking for a point that's both. That's why we use the intersection. Graphically, the solution of the system is the point of what between the two lines? We call it a point of intersection. And remembering that term, intersection, will help you in remembering how to work your calculator, because the calculator uses the same terms. A system of equations has been represented on this grid. The system has an integral solution. What's integral mean? What is an integral? Unit 1 review. An integral is? Yeah, it has to do something with an integer. It's a positive or a negative whole number. So integrals are positive, negative whole numbers. Do we have this graph? No, the graph's not on. Got deleted. We'll state the solution and write it what it means as an ordered pair from the last question again. The x was equal to 3, the y was equal to 2. There should have been a graph of this, meaning that the point was 3, 2. All we're trying to hammer home is that you're looking for where those points cross, and you're trying to figure out the x value, and you're trying to figure out the y value. And those represent certain things. What did the x value mean in our question? The price of an adult to enter. Correct. Where y represented the cost of a youth to enter. Now, those of you with graphing calculators, you're going to want to pull out your graphing calculator, turn it on. In the top left-hand corner, you got your y equals. Go to that. We're used to just putting one equation in. Now put both equations that we solved in. So I'll go back. You want to put these two equations in. So the first one, go y is equal to negative 2/3 x plus 4. And your second y should be negative 3x plus 11. You don't have to put a y. It's already there for you. So when it says y2 in your calculator, I think that's already in y. You want to go y is equal to y is equal to no. You have to put in that form. That's a good point. You guys are going to get questions in this form. You can't get that form into your calculator. It's not possible, which is why we switch it to slope intercept form. Josh?
When they were done in calculator,
Because you can adjust everything to be y equals, and that's just where graphs are always created. Because we always call our x are dependent and our y are, or our x are independent and our y are dependent. So y is dependent on x when you put in your calculator. Okay, hit window. Make sure your window's set to something appropriate. So on our graph we did 10 and 10, 10. If that would work perfect. If you already set to that, that's fantastic. I'm going to set mine to be minimum negative 10, maximum 10, scale of 1. Minimum negative 10, maximum 10, scale 1. Yeah, you would. You're right. So the y max actually, I'm going to make 12. Good observation, because it actually passed 10, didn't it?
So you want your x max
11. I make it 12 so you can see it. If it's 11, it just hits the top of the calculator and then you won't see it. Yeah, got it?
10, 10's random, right?
Yeah. Which one?
10, 12.
Okay, now hit graph. You should see both of these beautiful lines on your graph when you hit graph. Dawson, hit graph. Hit graph. You have lines? Yeah. Liam, you have lines? Yeah. Okay. This is where it becomes so useful. You want to go second trace. And number 5 is that beautiful intersect button. That's telling your calculator, I want to find the intersection between these two lines. So you go down, hit enter on it, hit enter again, hit enter again, hit enter again, and it'll give you the answer. What is it, Joe? 3, 2. So when I give you massive equations where the answer is like 31.63, it's going to be hell to try to draw that and get it accurate. So use your calculator. We're going to learn how to solve these things a bunch of different ways. On your test, you'll always have your calculator. It's a good little safety net for questions where it doesn't ask to show your work. Multiple choice questions, beautiful. You should be able to fly through them. The problem is, if you go back to your y equals sign, if you have more than one line in there, you need to delete it out. So, like more than the 2 lines that we wanted. So if you had a 3rd line, you have to get rid of it. Does that make sense? Yeah. If you had a 3rd line drawn in there, it might figure out an intersection for that 3rd line, which we don't want. All right. We already graphed it all. We did that. We already algebraically solved our system.